In example 3, we are going to sketch another rational function. Now the difference is, in numerator we have another polynomial 2x minus 3, and the denominator is same, 1 plus x. In this example we'll have to find the vertical asymptote. To find vertical asymptote, we can figure out by putting x equals to minus 1 in it. If we do that, we get 2 times of minus 1 minus 3 over 1 minus 1, which is minus 5 over 0, and that's infinity. So the vertical asymptote is still minus 1. So we'll note it down here, x equals to minus 1, and we have to make a dotted line here at minus 1. This is the vertical asymptote. Now to figure out the horizontal asymptote, we have to write our function in a slightly different way. So for that, we need to use a technique. We divide numerator and denominator both by the highest power of the x. So in this example, x power 1 is the highest power. So we are going to divide every term by x. So we divide 2x by x minus 3 over x and 1 over x and x over x. This gives us 2 minus 3 over x over 1 over x plus 1. Now if x becomes infinity, the y value will be, so if x becomes infinity here, we know that 3 over infinity is 0, so 2 minus 0 over 1 over infinity is also 0, so 0 plus 1. That means the y value is 2. So y is equals to 2 is the horizontal asymptote. So the asymptote is now changed. Moreover, we have to find the y-intercept, and for this we plug in x equals to 0 in it. So this is going to be 2 times 0 minus 3 over 1 plus 0, which is minus 3. So y-intercept is minus 3. And here we can also find the x-intercept if we plug in y equals to 0. So if we plug in y equals to 0, I'm going to write here 0 equals to 2x minus 3 over 1 plus x. So when we plug in y equals to 0, we get the x-intercept, which is 3 over 2. The x-intercept is going to be 3 over 2. Okay, now we also need to find the sign of y values near the asymptote. So if x values are very near to 1, say this, what are y values, positive or negative? So if I take a value of 0.5, say here, so it's 2 times 0.5 minus 0.5 minus 3 over 1 minus 0.5. So this is clearly a negative value now, because the numerator is negative and 1 minus 0.5 is positive. That's why the entire value is negative. So we start from the negative infinity then, and cuts the y-axis at minus 3. So I have to mark minus 3 here. That's minus 3. The graph is coming from the minus infinity, cutting y-axis at minus 3, cutting x-axis at 3 over 2. So maybe this is 1, this is 2, so 3 over 2 is between them. So graph is going like this. Now approaching the value of, since the horizontal asymptote is 2, so we also have to make a horizontal line cutting the y-axis at 2. So the curve is approaching this value now. The curve is approaching this line here. Now, if the x values are slightly less than minus 1, say minus 1.5, what are the y values? So we have to figure out. So it's y equals to 2 times of minus 1.5 is minus 3 minus 3 over 1 minus 1.5. So we see that numerator denominator both are negative. So negative sign is cancelled, and now the y values are positive. Now horizontal and vertical asymptotes remain same, and as x reaches infinity, y values are near to 2. So that's the horizontal asymptote, and as x reaches minus 1, from the left side y values will reach infinity. So that's the other part of the graph. This is the graph of y equals to 2x minus 3 over 1 plus x.